let us take a look at quadrants of a circle. Now, I'm taking a look at quadrant of a circle. Generally, angles are measured in anti-clockwise direction, and this measurement is done within a circle that is divided into 4 parts, and each of these parts is what is called quadrant of a circle. And therefore, there are 4 quadrants of a circle. Let us analyze the first quadrant. But before we analyze the first quadrant, I want you to look at this word C-A-S-T. I call it what? Cast. I call it cast. Now this means A. And this A simply means all. That is to say that in the first quadrant, all are positive. That is to say that sine, cosine, and tangent are all positive. So this A here means all. Now the S here means what? Sine. It simply means that in the second quadrant, that only sine is positive. That is to say that cosine and tan are negative. And then we move to the third quadrant. This T here means what? Tan or tangent. Simply means that at the third quadrant, only tangent is positive. And that is to say that sine and cosine are what? Negative. In the fourth quadrant, this C here means what? Cosine. It simply means that in the last quadrant, that is the fourth quadrant, only cosine is what? Positive. And that is to say that what? Sine and the tan are negative. And then, remember that the range of angle in the first quadrant is between 0 to 90 degrees. The range of angle in the second quadrant is between 90 to 180 degrees. At the third quadrant, the range is from 180 to 270. And in the fourth quadrant, we have from 270 to what? 360. Now you can observe that in the second quadrant, we have 180 minus theta degree. And the third quadrant, we have 180 plus theta. These are the main angle. And in the last quadrant, we have 360 minus theta. Now let me tell you how I got 180 minus theta. If I consider the second quadrant here, if I consider this circle, then coming to second quadrant, I draw a straight line that originates from 0 and then touches this what? Circumference. Now if I decide to extend this line, then I get something like this. Now I want to call this my angle, the angle between this, my diagonal, and this x-axis. Let me call it what? Theta. I want to get the angle from this x-axis till it touches this line I draw. So this is the angle I want to find. That is from here to here. How am I going to find from here to here? I hope you know that to get from here to here, it is from here to here minus from here to here. We give you from here to here. I come again. From here to here minus from here to here, we give you from here to here. And that is to say that from here to here is what? 180. Because from here to here is 90. From here to here is 90. From here to here is 90. 90 again. So from here to here is 180. And then minus what? This theta. Then I have from here to here. That's why the range of the angle in the second quadrant will be from here to here. And that's what? 180 minus from here to here. The one remaining from here to here minus theta. That's why in the second quadrant, the range of the angle is what? From 180 minus what? Theta. Now let me analyze the third quadrant. Why do we have 180 plus theta here? I will tell you. Now let us consider the third quadrants, make sure you pause this video and then from time to time, make sure you copy. Now, in the third quadrant, let us look at the range of angle. Why do we have 180 plus theta? Let's find out. If I also draw my diagonal to touch my circumference, and then I have something like this. Now, I want to get this angle. The angle between the x-axis and the diagonal. I call it what? Theta. And remember, to get my main angle, you will start drawing this line, from this x-axis until it touches your diagonal. And that is the angle I am looking for. And I hope you know, to get this angle from here to here, it is from here to here, plus from here to here. I come again, to get from here to here, it is from here to here, plus from here to here. And that will give you from here to here. So the range of angle in the third quadrant will be from here to here, that's 180, plus from here to here, and that's what? Theta. So it's what? 180 plus theta. That is the range of angle in the third quadrant. And that's why we have 180 plus theta. I hope you are following me. Yes, because we are going to solve some problems after here. Now, we now look at the last quadrant, 360 minus theta. How do we get the range of angle here? 360 minus what? Theta. I also explained again. So coming to the last quadrant, I also draw my diagonal to touch my circumference. And then I have something like this. And then you now find your angle between x-axis and the diagonal. This is the angle theta. Now you are looking for, start drawing your line from this x-axis until it touches your what? Diagonal. This is the angle from here to here. This is the angle I'm looking for. And to get this angle from here to here, I hope it is from here to here, that is 360 minus from here to here. I come again, to get from here to here, it is from here to here minus from here to here. If you remove from here to here, that's 360, you remove it from here to here, what remains is from here to here. So the range of angle in the last quadrant is 360 minus what? Theta degree. And that's why we have this 360 minus theta. I hope you are following. Yes. Now let us take a look at one question. Let's take a look at one question. Now we take a look at this question. Sin 235 degree is equals to dash. So let us evaluate the following angle. Now, step 1. Ask yourself, what we have here is 235 degree. Now, 235, what range of angle does it fall? 235, I guess, fall into third quadrant, which is from 180 to 270 degree. Remember, 235 cannot fall into the second quadrant, that is from 90 to 180. It cannot fall into it. But 235 is above 180. So that 235 falls between this what? Range of angle. And that is third quadrant. So having done this, that this 235 degree fall in third quadrant, and look at the range of the angle in the third quadrant, 180 plus theta. That is to say that 180 plus what angle will give you this 235? Will give you 235 degree. I come again. 180 plus what angle will give you 235 degree. I don't know the angle and I call it what? Theta. So from there I now get my what? Theta. So making this theta becomes what? 235 degree plus 180 crossing here becomes what? Minus 180 degree. Now when you subtract, I hope, what are you going to get when you subtract? So when you subtract, 235 minus 180 should give you 55 degrees. So theta here is 55 degrees. Therefore, I can say that what? That sine 235 degree will give you the same range, and that's what will give you 180 plus theta degree, and this is equal to minus sine theta. Now, please, I want you to take notes. It is minus sine theta because at the third quadrant, sine is what? Negative. That's why it is equal to minus sine theta. And therefore, I can tell you that sine 235 degree is equal to 180 plus my theta is what? 55 degree, and then it will now give you equals to minus sine what? Sine 55, because your theta is what? 55. So I can say that sine 235 degree is equals to sine 180 plus 55 degree, and it is equal to what? Minus sine 55 degree. Now, this is the range of the angle. That's why if you press 180 plus 55, whatever you get, if you press the sine of this angle, what you will get is also equal to what? If you press the sine of minus sine 55, you will still get the same answer. So we now look at II cos 235, the same thing. 243 lies in the third quadrant, and remember in the third quadrant that we have 180 plus theta. So because in the third quadrant we have 180 plus theta, I will now say that 180 plus what angle will give you this cos 243. So because it is cosine, I can say cos 180 plus what angle will give me cos 243. Cosine will cancel cosine, so we have 180 plus theta is 243. To find your theta, this one cross becomes 243 minus 180. So if you subtract 243 minus 180, minus 180 will give you 63. So the angle is what? 63 degree. So you go here and substitute it, and therefore we can now say, permit me to clean here. So we can now say that what? Cos this angle, that's what? Cos 180 plus theta is what? 63 degree will also give you, remember that cosine is what? Negative. So minus cos 60 what? 3. So when you press your calculator, 180 plus 63, if you press the cosine of it, what you get will also equals to if you press minus cos 63, what you are going to get here will be equal to what you are going to get here when you press your calculator. Okay. Now let me look at this last one, tan 220. Don't worry if you're not following, you are going to follow it now. Now let us look at the tan 222. Now tan 222, 220, I guess it falls between this third quadrant of a circle, and in that third quadrant we have the range of the angle 180 plus what? Theta. And then what do I do now? And it is talking about tangents. So I can say tan this range of angle. I will now say, since the question is talking about tan this range of angle, and that's what? Tangent 180 plus what angle will now give me tan 220 degree. That is what I mean. Since the angle in question is tangent, and I say tan this range of angle plus what angle will give me tan 220. So at this point, this will cancel this. I have 180 plus theta will give me 220. So theta is what? 220. 180 going becomes what? Minus 180. Theta becomes, if you subtract 220 minus 180 will give you 40 degree. So we have here as theta as a 40 degree. So having gotten my angle as 40 degree, I will now go back and put it here, and therefore I can tell you that since it is talking about tangent, that tan 220 degree is also equals to tangent 180 plus theta, and that is equals to tan what? Theta. Remember why it is plus here? Because at the third quadrant, tan is what? Positive. That's why it is what? Positive. Unlike cosine, that is what? Negative, because cosine here is what? Negative. So, but here tan is what? Positive. And therefore, tan 220 degree is equals to tan 180 plus 40 will give you tan 220 degree, and then it will also give you, I hope you know how I got it, because your theta is what? 40 degree. So 180 plus 40 will give you what? Tan 220. So let me write it here. So I have 180 plus theta is what? 40 degree, and it will give you equals to what? Tan 40 degree. What I did is simple substitution. Since my theta is 40, any place I see theta, I put what? This 40. So that's how I got it. That's why if you press 140, 180 plus 40 should give you 220. And that's why if you press tan 220, it will also give you what? This tan 40. If you press it, you can try it in your calculator. Press tan 180 plus 40. What you get will also be equal to what? Tan 40. And also press tan 40. You are going to get the same thing. Just simply add 180 to 40 and then press the tan. Whatever you get will be the same answer to when you press tan 40. So let me summarize. In summary, what I'm trying to say is this. In summary, what I'm trying to say is, at the second quadrant, let me start from second quadrant, our range of angle is 180 minus what? Theta. Then, if I link it to sine, then we have what? In the second quadrant, I have a sine. The range of angle is what? 180 minus theta. And that will give you equals to what? The same angle, sine. And that will give you sine what? Theta. Notice that this sine is positive because it is at the second quadrant. And at the second quadrant, sine is what? Positive. And also, let me move to cosine of this angle. For cosine of this angle, we have cos bracket what? 180 minus theta, and it is equals to what? Minus cos theta. Notice that this minus is here because at the second quadrant, cosine is what? Negative. That's why you see it here. And then let me move to tan. Now, tan of the range of this angle, and that's what? Tan 180 minus theta will now be what? Minus tan what? Theta. So this is what I will have in my second quadrant, and that is what this is the principle I used in solving the three questions I solved now. So we now move to third quadrant, and the range of the angle is 180 plus what? Theta. So let us get the sine of this 180 plus theta. So at the third quadrant, we have, from the sine, we have what? Sine the range of this angle, and that is what? 180 plus theta degree, and that will be equals to minus sine theta. Notice the minus sign in this sine theta, because at the third quadrant sine is what? Negative. Then we now look at what? Cosine of the range of this angle. So cosine, cos of 180 plus theta will now give you what? It will give you cos theta. But it will carry what? Minus sine, because at the third quadrant cosine is what? Negative. And then we now look at what? Tan of the range of this angle. So we have what? Tan 180 plus theta will give you what now? It will give you tan theta. So notice that this tan is what? Positive, because tan is what? Positive. So this is what I will have in my third. Then in my fourth quadrant, the range of the angle is 360 minus what? Theta. And then let me get the sine of this range of angle. So sine of this angle is what now? Sine bracket what? 360 minus theta, and that will give you minus sine theta. And you remember that this minus is so because here sine is what? Negative. Now let me get cosine of this range of angle. So we have cos 360 minus theta will give you cos theta. Notice that there is no minus here, because at the fourth quadrant cos is plus. That's why there is no minus. There is no minus here. And then we look at what? Tangent of 360 minus theta, and that's what? Minus tan theta. And I guess you know why it's minus here, because there is minus here. So this is the range of the angle in the fourth quadrant, and that is the basis of the question I solved here before. Now let me also use this to illustrate one more solving. Now if I ask you to solve for me sine 145 degree. If somebody asks you to evaluate 145 degree, sine 145, so 145, I guess it lies within the second quadrant of the circle, and in the second quadrant of a circle, the range of the angle is 180 minus what? Theta. So I'm going to use this connection, and since the question is talking about sine, I will ask myself, sine of this angle, and that is what? What sine of 180 minus theta will give me this sine 145 degrees. So sine, we cancel sine here, and that is what I have been doing since. So allow me to clean this place. So we have what? 180 minus theta is equals to 145. Remember your target. Your target is to find that theta. So to find theta, this minus theta crossing this sign become plus. And this is what? Plus 145 crossing here become minus. So I have what? 180 plus 145 crossing become minus 145 becomes equal to minus theta crossing becomes what? Plus theta. So if you subtract, what are you going to have? 180 minus 145. 180 minus 145. Sorry. 180 minus 145 should be giving you 35 degree. So here your theta is 35 degree. and I want you to move back to this place, and that is what sine 180 minus theta gives you sine what? So I can say any place you say, okay, what we're supposed to have is a sine what? Theta, because this sign is what? Positive, because it is what? Second quadrant. At the second quadrant, sign is what? Sign is positive. That's why I guess you remember how I got this. So at this point, you substitute your theta, and then we have what? Sine 180 minus your theta is what? 35 degree is equals to sine 35 degree. So if you subtract, if you subtract 180 minus 35, whatever you get, if you press the sign of it, the answer you will get will be the same thing as when you press sine 35. Try it. If you subtract 180 minus 35, whatever you get, you press the sign of it, whatever you get must be equal to what? Sine 35. And that is it. Alright. Now we now look at what? Allied angles. Allied angles are those angles that are greater than 360 degrees. Those angles that are greater than 360 degrees are called allied angles. And how are they evaluated? They are evaluated by subtracting 360 from them and then locate their position in the quadrant of the circle. Allied angles are those angles that are greater than 360 degrees, and they are evaluated by subtracting 360 from them